don't understand Lars at the best of times. So hi, everybody. Thank you very much for having me here today. Thank you to all the organizers for inviting me here today. It's been an amazing day. My name is Kris Howard. I am the head of developer relations for AWS in Asia Pacific. The accent, as you can tell, I didn't grow up here, but I have lived in Australia for like 20 years now, so it's not going anywhere. My pronouns are she, her. Yes, I firmly believe that pineapple does belong on pizza. And yes, hashtag pineapple. If you have seen me before in Melbourne, you may remember before I joined AWS, I actually worked for Yao Conference. And so like sort of 5-6 years ago, I was coming down here all the time and speaking at meetups and conferences in Melbourne. You may, as Lars have said, have seen me talking about how knitting patterns are like computer code. You may have even seen me wearing a dress covered in the AWS logo. Yes. I've had like 5 people today be like, Kris, why aren't you wearing the dress? Okay. So first of all, it was never intended to be a uniform. I'm not like some Elizabeth Holmes weirdo. And secondly, like I feel like you've kind of had enough AWS logos shoved in your face today. I don't need to be swathed in it, all right? So if you do want to connect with me on social media, I am web_goddess. I am that on the Bird site, but I don't use the Bird site anymore. I'm on Mastodon. Please come into the Fediverse. The water's great. We're all having a good time over there, so come join me over there. And so if you did see me in Melbourne back in the day and you're wondering why the hell you haven't seen me in a long time, it's because I spent the last 2 and a bit years in Munich, Germany, eating pretzels the size of my head and washing them down with liters of really good beer. And you guys, it was amazing. And explaining to many confused Europeans that yes, I did voluntarily move from Australia to Germany. They just couldn't quite wrap their head around that. But I'm not here today to talk about knitting. Sorry, Lars. I am not here to talk about pretzels or beer, although we will be having beer in like 30 minutes, so I promise not to stand in the way of your beer too much. But I actually thought quite a bit about what I would talk to you all about. I'm not, Kris, going to talk about eventual consistency, but you know, I talked to Lars. We had an epic Facebook thread about this. I talked to my colleagues in the serverless team who are here, Paul and Stephen up the back there. A lot of discussion over what I would talk about, because we've had a lot of technical deep dives today, okay? We've had idempotency, we've had load testing serverless backends, we've had TypeScript and AI/ML and IoT. And unlike everybody else who's presented, I'm a manager these days, okay? I have not shipped code to production in a really long time, and so I'm not going to give that sort of talk to you. You know, I would be a complete fraud if I did that. So instead, I started thinking about connections. I started thinking not just about, everyone's having difficulty with their clicker today. Not just about the connections and how we connect as a community, and that is a picture of Pete Hansons, by the way, who's one of the organizers. This was him at an event in Sydney just a few weeks back. And this is my first event back since moving back. We moved back 2 months ago, so this is my first in-person event back in Australia. But connections, also how we connect the software that we build. And so I thought what I would do today, just look, you've had a lot of technical deep dives. I'm not going to go that deep. Instead, I want to talk about a lot of these words we've been throwing around. You know, events, event-driven. Michael said, I don't even like serverless. I just want to call it event-driven. What the hell does that actually mean? I want to give you some advice. You've heard about a lot of different technologies today, a lot of different products and frameworks and services. How do you pick one? You know, how do you avoid the trap that Jeremy talked about this morning of like just using the one that you know really well and therefore you use it for everything? And I also want to maybe challenge some conventional wisdom. You know, things like, is it always bad to be tightly coupled with your components? And if it is, you know, how loosely coupled should you be? And so I think it's very easy for us all to fall into the trap of thinking that our ultimate goal is always to decompose everything. You know, break it down, decompose all the things, take everything down into the small possible services, decompose all the things. And I would put to you that there actually are times in life and times in software where tight coupling, where tight connections are desirable. It's a good thing. And so loose coupling is often a good goal. It's often the thing we want to do, but it's not a black and white situation. Because after all, like the easiest and best way to loosely couple 2 systems is not to connect them all in the first place. It's not super useful. I don't recommend you do that. And so people have been wrestling with this question of how we connect our software systems for literally decades. Like this quote, David Orchard, BEA Systems, they were founded in the 90s. And so, there are a few of us Gen Xers here, but I know that many of you were not alive in the 90s. And you might think that like, hey, Kris, like now we have all this cool technology, right? We have the cloud, we have serverless, we have cool stuff like NoSQL databases and streaming and event buses and things like that. But you still have to actually use it to make sensible architecture decisions and to understand your design trade-offs. Because if you don't, you fall into a trap. You could end up, decomposing tightly coupled piles of code into ever smaller, loosely coupled piles of code, as Vlad Kononov put it. And that is like my single favorite slide from a TED Tech Talk ever. It's a really good talk. You should look it up and watch it. Okay, so before I joined developer relations at AWS, I was a solutions architect. I managed a team of SAs. And the first thing that we would teach new SAs was whiteboarding, how to draw really simple architecture diagrams. And so when we think about modeling connections, often we're just talking about drawing boxes and connecting them up with lines. And so you've seen a lot of different architecture diagrams today. I'm going to show you two more, just to illustrate why connecting systems is so difficult and so important. And this is the point at which I am contractually obligated to let you know these two designs are very much the hallmark of our beloved colleague, Gregor Hoppe. He uses these all the time. It's his personal, bugbear. And Gregor's thing is that people place way too much emphasis on the boxes and not enough on the lines. And so these two very simple systems, they use the same components, okay? We've got A, B, C, D, same on both sides, but they're wired together differently. On the left here, we've got, sort of a stack, maybe a kind of a layered architecture, and on the right, we got something completely different. And so if you look at this from an architecture standpoint, you can immediately start noticing and drawing some conclusions, like they may be made up of the same components, but the lines mean that these systems have very different behaviors. On the left here, we've got very clean dependencies. It's pretty easy for me to drop out C and swap in something else. On the other hand, like I might have longer latency. I've also got a single point of failure. Like what happens if C goes down? A is no longer able to talk to D. So we do have here some advantages, but some disadvantages. Then you look at the other side, and it's pretty much completely the opposite. Like it's a lot harder here to actually replace any of those components, but you also have short paths. You've got resilience. And so the conclusion Gregor draws from this is that your architecture diagrams only tell you so much. And in fact, he says if you don't put the lines on the diagram, it's actually not an architecture diagram at all. Because the lines are the things that tell you about essential properties of the system. And so if you don't show the lines, you're not actually capturing the full picture of how your system's going to behave. And also, I really would just want to emphasize that your architecture is not your bill of materials. It's not the list of the boxes, okay? It's how you put it together, and more importantly, why you put it together that way. And look, there are a lot of technologies that you can use to wire up your boxes together, and obviously I work for a vendor, we make some. And so a lot of questions that we would hear from customers is like, okay, well, which thing do I use when? Like, when should I be using AppFlow? Or like, when should I be thinking serverless and using like, Lambda and EventBridge and stuff? And I've put AWS up here, of course, because that's what I'm familiar with, but substitute, as needed. And I think people really want there to be like one answer for each case, And I think that they can get to it by like reading the technical documentation, reading about each service, seeing which one matches the thing they want to do, and great. Like that's obviously the way to go, right? But I would caution you there's a little bit more nuance to it than that. The joke for every SA in the room is that we always say it depends when you ask any question, and I'm going to say it right now. It really does depend here. Okay, there's a lot of different factors that you should be considering when you think about these tools. Like one factor there is how much control you have over the boxes. Like that is going to make a big difference on what lines you can draw. Another one is who's actually making the connection. Is it the same team that built the boxes? Is it another team? Is it a third party? And a really important third question is, when is this happening? Is it happening after the fact? Like these are boxes that already exist and we're joining them up because we want to do something specific? Or are we building a distributed application where this is all happening at the same time and the same team that built the boxes is doing the wiring up all at the same point? So again, no hard rules here. All of these tools and approaches, they have their purpose, but you need to understand the context in which you're drawing these lines. And really, that's the difference between integration and building distributed systems. You know, I think we understand often integration means it's something you're doing after the fact. Maybe you have less control over the boxes, and you're likely a separate team even. Versus building distributed systems where you're actually building the lines and the boxes at the same time by the same people. And it's important to understand because it impacts the level of coupling that you can afford. And so I really want to urge you, when you are making these product decisions, like, don't just solely look at the list of features in this great new framework or the product that you're considering, but think about the context in which the work is taking place and the level of control that you have over the different pieces. Okay, so I have satisfied Gregor, I've told you, I've emphasized why the lines are really important. Okay, so what do the lines actually represent? So we've seen a lot of architecture diagrams today. Here is the simplest one in the world. We got A, and A does something with B, okay? Maybe, I don't know, it could be anything, but this is really simple. Like, you might think there's not a lot of ways that this can go wrong, but there's a lot that we could actually tease out of this. Like, what's the interaction model we're talking about here? Is it like an RPC? Is it messaging? Is this synchronous or asynchronous? Is this point-to-point? More importantly, is this data or control flow? Like, maybe we've got polling. Maybe B is polling, and so B is actually controlling, but the data is flowing from left to right. And like, what actually is the data format? You know, are we talking big endian? What are actually our A and B anyway? Are they systems? Are they instances of systems? There's really no way to tell just from the simple diagram. And you can take it even further, like, are we building a distributed system? Because then you got to worry about things like partial failure. Like, what happens if A throws an error? Can I retry? What happens if I retry? Am I going to have to think about idempotency, like Eric talked about today? You know, can I actually retry too much? Could I actually bring A down if I do that too much? And now I need to think about back pressure. So really, there is a lot that you need to consider just with a very simple diagram of two boxes and a lines. And software architects need to understand all this stuff. The good news, of course, is that a lot of the technology, it will take away some of this burden for you. It will take some of this off of you. But some of this stuff, like, you can't escape from. You're just going to have to deal with no matter what you do. And so you really need to keep this in mind when you're making these decisions. So real-world example, this is the kind of story that we would hear all the time talking to customers, and I'm sure that, you know, some of you today are in teams like this. Like, you're excited, you found a new tool, a new framework. Yay, you're going to be asynchronous, you're event-driven, it's pub-sub, you know, throwing lots of buzzwords out there, like side effects and components, and you know, this all sounds really cool, and I'm glad you're excited. But again, you know, just as we did with the boxes and the lines, we can tease out a lot of detail from this. Like, first off, there's an interaction style that's sort of implied here, you know, messaging. They're using messages as opposed to, say, RPC. There's a temporal, a time-based component to this. They're doing this asynchronously. They said they're using publish-subscribe as their composition model. So like, maybe if they have two listeners listening for something, each of those listeners has to get a separate copy of the message, as opposed to, say, having like a worker pool, and they have competing consumers. They also say they're using events, and we'll talk a little bit more about whether they really are and what events are, but they take it a step further. They say they're event-driven, and I would submit to you that actually only your application can make it event-driven, make your system event-driven. And of course, they're probably deploying this, you know, in a distributed fashion, which might mean the cloud, but it's really hard to tell. But my point here is, like, yes, they're super happy with their technology choice, but they might not have realized when they made it all the other stuff that was going to come along with that. You know, maybe all of this stuff they really did want, maybe some of it they wanted, but maybe some of it they sort of took on without actually realizing it, without actually realizing that they were going to get that. And so when you are choosing between these technologies, like, do not do, as Jeremy said, don't just use the one you know for everything. You do need to actually make some choices here. But really the important thing is to separate your architectural thinking from the product selection. And a lot of excellent technology products. I've put some AWS ones up here. I've put, you know, managed streaming for Kafka, SQS, SNS, Amazon MQ. They're all great, but the point is they all come with different behaviors, different trade-offs. And just in case any of my colleagues are cringing, this is not intended to be an actual product comparison slide. Please don't examine it too closely. The point is just to show you need to consider the full package you're getting, the full bundle, and make sure that the properties you're getting with a given product, they're actually ones that you're after. And so, maybe you get everything you wanted. Maybe what you choose doesn't have everything you want. You actually need to combine a few things together. And notice I've put question marks for event-driven because, again, your communication method, your messaging product, that can't make you event-driven. Only your application can. So again, don't think about just the boxes. Don't think about your architecture as a set of boxes and bill of materials. You have to think about the desirable properties that you want your system to have and find technology that actually supports that. And it might be, as I said, it might be that it doesn't have everything and you need to combine some things together. But just keep in mind, there are 2 levels of consideration, not just 1. Okay, going back to the connections again, going back to that line between the boxes, another aspect of it is how thick is it? And by that I mean, how tightly or loosely coupled is that connection? And actually, what does that even mean? So coupling is a measure of dependency, of course. Inversely, it's a measure of independent variability. So we've got 2 things, and the idea is if a system is loosely coupled, if a change happens over here on one side, if I make a change or a change just occurs, that change doesn't propagate through to the other side. The connection in the middle kind of absorbs that change. And that can be a design time change, it can be a runtime change. Maybe B has a new version, new features come out, we've upgraded B. And so that can be a design change. Maybe it can be a runtime change. Maybe there's latency, maybe there's intermittent failure. And so it's really important to know that decoupling things is valuable. It is valuable, but it's not free. There's a cost. There's a cost at both design and runtime, and it's another one of those things where it depends. And so there's really no black or white here. And I loved, if I can refer back to Kris's talk, his point about talking to the business people. I used to be a BA also after I was a developer. I was a business analyst. And I think a lot of times we throw around these buzzwords, and what I really want to encourage you to do is to try and make them as understandable and accessible to other people in your business when you're making these decisions, because making decisions about coupling have a lot of impacts. They're very important. They have consequences. And they often involve making a lot of assumptions. And oftentimes, other people in your org are the best place to tell you if your assumptions are correct or not. It might be the business or the product people, because coupling is all about change and change propagation. And the product people are actually the best ones to tell you about change because they know what they're thinking of doing next. And so it's really important to involve them in these conversations and try and not lapse back to buzzwords. So how do we do that? Well, we need to explain these terms in easy-to-use, terminology. So we said coupling, it's a measure of dependency, okay? It's how tight our connections are. It brings some benefits, It limits the change. It can limit a runtime error blast radius. When is loose coupling most useful? I submit to you, it is most useful when you have frequent changes and less control. Because after all, if things never change, well, then just couple them and you're fine. There's no need to actually, uncouple them. And also, if you have full control over both endpoints there, well, if you have a change, well, guess what? You can just fix it on both sides and you're fine too. So clearly there are times when loose coupling is more valuable and times when it's less valuable. And look, there's a lot of other things here that you can go through. But really what you're going to be doing here is you're going to be explaining these things and you're going to be translating them into benefits. And so obviously loose coupling, it limits the change radius at design time. It also limits the error radius at runtime. And to us, cool, right? Like that's an obvious benefit. You might need to take it a step further. Like it might not be that to a non-technical person that why these are desirable qualities to have. So you got to take it a little bit further. So why do we want to limit a change radius? Well, because then you can move faster. You've got more agility. You can, accommodate more change. And yes, that's obvious to us, but you might need to hold their hand a little bit here. And limiting error radius, well, that gets you more reliable and fault-tolerant operations. So you can put that in words they use, but the important thing is you also have to give them the caveat there that you have to balance this. There is a cost for doing this. And that can be a dollar cost, but it could also be a complexity cost, because loosely coupled systems just simply have more moving parts that you have to worry about. It's also really important that you and they understand that there is no one thing you can do to like tick the box and great, our system is now loosely coupled. Like there are any number of different things that you could be doing that affect your coupling. Like are you using JNI or something that ties you to a virtual machine or a specific programming language? How are you actually identifying B to talk to B? Are you using a hard-coded IP address? Are you doing a DNS lookup? Do you have like a channel name? How do you actually handle the data formats? Like how do you handle strings? Is null the same as empty? Are fields optional? You know, you go down this whole list all the way down to the conversation, like fetching data repeatedly. Like I've got part of a data set, I want to get some more. That's actually coupling, because both sides of that have to actually agree on how that's going to work. And so there are a lot of different dimensions here that you need to keep in mind and understand so that you can understand the trade-offs that you're making. And so this really, I'm sorry to say, is the answer to the question of how tightly or loosely coupled you should be. There is no single answer. It's not true that loosely coupled is always better. But one heuristic that's often really useful is that the more control you have over the endpoints, the more coupling you can get away with. Because look, there's a lot of tooling, your CI/CD pipeline, automated testing, you know, IDEs, where you can detect breaking changes and actually deal with them before they cause big problems. So that's my pitch to like not just rely on buzzwords, not just rely on chasing ideals. I want you to understand the trade-offs that you're making and make sure you're considering all these decisions, all these nuances when you make your coupling decisions. All right, very quickly on messaging and events. I said I was going to talk about events. What are events? We've talked about events all day today. Events are messages. Messages are an interaction style. And again, this goes back to one of Gregor's books, Enterprise Integration Patterns. He says messaging is like the simplest interaction pattern, okay? You take some data, you bundle it up, and you're actually going to transport it from A to B. And so events are actually a specific type of message. You know, we actually give semantics to this bundle, which means that it can say different things. It means something slightly different. We can use a command, like we can actually tell B, go and do something. We can actually transport a document. We can say, here's a new order, here's a new purchase, or we can notify about an event. And it's really important to notice that there are distinctions there. You don't want to blur this together, and there is a great blog post from Martin Fowler where he talks about what he calls passive-aggressive events, which is where you've got an event, but it kind of implies a command at the same time. And he uses this example of like a purchase happening, you know, and instead of just a pure notification, it's like, hey guys, purchase has happened, like be really cool if you could tell me about payment processing, rather than just actually saying, do the payment processing. And so he warns you about this because you've compromised the event at that point. An event is a notification that something happened, and you really shouldn't be expecting to get something back when you're actually talking about events. And so this is just, it's subtleties of language, but if you build an architecture where you think you're calling something in events, but really you're assuming, your system is assuming a lot of things that actually make it more like a command, you might think you've built an event-driven system, but actually not so much. Okay, and so Michael sat here and he talked about event-driven. What does event-driven actually really mean? We use event with a lot of different ways. So again, I think Martin is has a really good breakdown of what these terms mean. I'm going to go through them really quickly. But yeah, one way we think about events is just pure notification. Like this is an example of an insurance company. And so something's happened. Customers changed their address, right? And so in this case, there's no state actually transferred with that. The other party, which is in this case the policy quoting, actually has to go back to the sender and say, cool, address changed, what's the new address, right? And so, yes, we've got some coupling here, potentially not great, but on the other hand, we've got no data duplication. We don't have an eventual consistency issue here. We've got a single source of data. So this approach does have some advantages to it. Martin also talks about an approach where you transport the state with the message. So now you've got more independence. Instead, policy quoting here doesn't actually have to know what customer management is at all. It just knows customer address has changed, it's got its own data store, it can work and scale independently, it can work locally. But here you've got data duplication and you've got possible data drift. And he calls this event-carried state transfer. And the next one here is what we call an event-sourced system. This is actually really different. Event-sourced systems are ones where the sequence of events is sufficient to actually rebuild the entire system state. So we're not really talking about messages and communication here. We're actually talking about how the state of your system derives from the sum total, the sequence of all those events. And so the easiest analogy for all of you is just a version control system, okay? Where the log of all your commits is the event state, and the working copy of the source, is the event store, and the working copy of the source tree is actually the event state. So that's event sourced as opposed to the other two. And lastly, just for the sake of completeness, CQRS, which is really where you've got separate data structures for reading and writing information. And look, this is actually something totally separate. You can use CQRS without actually having to use events, but it's often used with the other patterns, and so it often gets pulled into this conversation, so just included it here for completeness. And look, I've gone through these very quickly. I do urge you to check out Martin's blog post, because he goes through it in a lot more details. We're getting very close to the beers. I want to talk very briefly about orchestration and events. Like, there's some really great orchestration tools. I really like AWS step functions. We talked about it a little bit today. And sort of orchestration kind of implies a certain, system image here, that there is this central entity that is controlling, that actually is where all the state of our system is in one place. And this has got advantages, It's very easy to know what's where, how long things are taking, and the other participants in the system can become pretty passive and dumb. Like, they just get told, do a thing, and they don't actually have to know what's coming next. Like, the orchestrator handles all that. So this has some decoupling. It has some nice properties. How does this compare to event-driven? Well, with event-driven, of course, all the events are going from A to B. You've just got a big jumble of everything. We've got orders being placed. We've got payments failing. We've got inventory warnings. And there's now no longer a central entity who's actually directing what happens and in what order. You've actually got event subscriptions, and the event publications are kind of doing that together, perhaps with event routing, maybe with Event Bridge. And so what often happens in these systems is that you've got all these events flowing, but you want to have a little bit more visibility. You want to see what's going on. And so you can actually use state machines for that, but using them in a different way here. You're actually using them for observing, to observe what's going on. By correlating, by matching to a sequence, you can actually sort of derive higher level events from this. And so a really classic example is like a pricing change happens in a retail site, and suddenly orders for the thing, go through the roof. Well, if you have a state machine who's actually doing this correlation, doing pattern matching, you can actually go, oh, I'm going to call that pricing mistake. That's probably what that was. And so these are actually very similar elements here, but very different actual architectures. Big red flag, of course, when you're talking about this stuff. This comes straight from our documentation. Event-driven architectures are great. They have very dynamic runtime properties. And so we very clearly give you a warning, you can create an infinite loop, all right? You got events going everywhere. Maybe you've configured it so that when an address change happens, something gets repriced. But elsewhere, you've specified that when something gets repriced, an address changes, and boom. So the loose coupling that you gain at design time here leads to this more dynamic runtime behavior, but you need to be prepared for that. You need to have cost control in place. You need to have back pressure on your queues. You need to be ready for this, because this system has dynamic properties, and presumably you wanted that, because if you didn't, you shouldn't have made it loosely coupled in the first place. Just if you don't need it to be dynamic, just couple everything, and you don't have to worry about this stuff. So just wanted to flag, dynamic systems are really useful, but there is more of a burden to you on managing that stuff. And my very last topic here, last couple slides, I want to finish up by just looking quickly. As I said, some of the new technologies that we have in the cloud do make some of this stuff easier for you. They're influencing how we deal with distributed and event-driven architectures. And really it's all about automation, because without automation, the cloud is basically it's just a data center, okay? So if you're talking cloud native, you have to be talking about automation. And this is serverless day, so let's look at this from a serverless lens. Well, what's involved with automation? Well, provisioning. We don't really need to provision anything. It's serverless, like it's auto-provisioning. That's kind of the point. Deploying is often super easy, or there's nothing to deploy. Or like if you're configuring an event bridge, are you actually deploying anything? Like it's actually just there and running. So in serverless land, what we're really talking about is composition here in automation. We're talking about wiring the pieces together, about connecting the boxes up. Like here's a Lambda, here's an SQS, here's an event bridge, and we're going to wire all these pieces together. We're actually going to draw the lines on the boxes. And a lot of different ways you can do this. I want to give a shout out to CDK, AWS Cloud Development Kit, because CDK automation is really massively helpful when you're building these kind of event-driven, messaging-oriented applications, because it allows you to do that composition in a programming language, just like you write your application code. So this code here, it looks like a normal line of code, but this is not application code, this is composition code. It's actually instantiating a bank. It's actually telling it the name of a channel, the mortgage quotes bus, which is something that EventBridge is listening to. And so with CDK, you can start expressing the shape of your application, the things that you're wiring together, and you can express those patterns as code that is actually going to be executable. It's actually going to deploy the serverless infrastructure for you. And this really changes the way you think, because you're no longer thinking about first building the boxes and then wiring them up. You can do them at the same time and in the same language. And eventually, if you take this a few steps forward, you can be creating fluent APIs like this. Like, build me something with scatter gather, do some filtering on the message, on the content, and then when you execute this, you get a running system. Like, I'm sorry, Michael, it's not quite Alexa doing it, but it's pretty damn close, okay? Because because the cloud is fully programmable, that's really the big difference from back in the 90s, okay? We're no longer doing that composition manually. It's all automated. So the whole discussion about what's in your boxes, how you're going to wire your boxes together, that just becomes a programming exercise, and that's a big shift. You describe the intent and flow of your application in code and not anymore in documentation. So I'm at time here, so I'm going to wrap up. I talked a lot about boxes and lines, how the lines are really what define the essential properties of your system. I talked about the nuances of connecting systems together, how there's no easy black and white approach to which technologies to use. Just remember, separate your architecture from your product choices, okay? We talked about how loose coupling is not always something you should aim for. We talked a bit about events, the difference between some of the different event-oriented patterns that are used. I talked about some of the modern technology that the cloud has to make automating all this stuff easier, and how you can code the boxes and the lines at the same time. And of course, we all collectively, as a community, confirmed that pineapple does belong on pizza for all time. I'm sorry, Eric, that's the answer. And so thank you again to the organizers for having me here today. This was a lot of fun. If any of you are coming to Sydney for the summit next month, I will be there in the damn AWS dress, and I would love for you to see it. So come say hello.